Yesterday, April 30th, 2025, I went to MIT and asked some thought-provoking conceptual physics questions to the students and graduate students. This presentation is 2 conceptual questions. The first one is a warm-up. It's a little challenging, but it won't leave any long-term scars. The second question ended up being a real challenge, even for the physics graduate students. Compare how your knowledge stacks up with the MIT students. Question number 1. A ball is projected horizontally from the top of a building with a certain speed. Exactly 1 second later, a second ball is projected horizontally from the same point with the same initial speed. At what point during the motion are the 2 balls closest together? What is the time difference between when each ball hits the ground? Here's an animation to help visualize this. This animation is from FET at the University of Colorado. Here's a cannon which will fire cannonballs horizontally from the top of a building. Let's fire 1 ball. I'm going to pause the animation. The ball left the cannon with a horizontal velocity, and it begins to follow a projectile motion. After 1 second, let's shoot another cannonball. As these 2 balls fly through the air, are they getting closer together or farther apart? Once one of the balls hits the ground, an external force acts and the kinematic equations are no longer valid. It's no longer a situation of constant acceleration.
So what's your name?
I'm Haley.
And are you a student here?
Yeah, I am.
What do you study?
I study AI.
Okay, and what year are you?
I'm a senior.
Okay, awesome.
So I would say their horizontal speed probably goes unchanged, but then there's gravity bringing them down with a non-uniform speed. Maybe at the bottom.
At the bottom?
The trajectory.
Luke.
And what year are you?
A junior.
Okay, what do you study?
Math and physics.
Oh, perfect.
Well, so their horizontal velocities always stay the same. And then the vertical velocity keeps increasing.
Bingo!
So as you move further and further along, the horizontal separation should stay the same, but the vertical should keep increasing. So they should be closest together when there's no vertical separation at all, and you only have the horizontal separation, which would be right at the beginning.
Okay.
Fantastic.
Great answer. Good. You're a student here, I assume.
Yep.
You're walking through MIT with the backpack on. What do you study?
Mechanical engineering.
Okay. What are you, an undergrad or grad?
Undergrad, sophomore.
Well, yeah, they're going to both hit the ground, but it's
So then when they both reach the ground, they're going to be
no,
closest.
because once the first one hits the ground, then it no longer. Your answer is kind of well, it's got to be before the first one hits the ground.
Before the first one.
Anytime before. It can be the instant the first one hits the ground, but it can't be after the.
Wouldn't it be the same? Wouldn't it be the closest at the same every time?
No, because the one in front is always moving quicker.
I see. So then it would be the same. It would be the closest in the beginning.
Oh, good.
My name is Wei Mo. Oh, I'm a postdoc here.
Oh, you're a postdoc?
Yeah, in computer vision AI.
In what?
AI major.
Okay.
Yeah.
Where did you do your PhD?
PhD Adelaide University, Australia. I think in real world nothing will happen. They just go follow their original trajectory, right?
Yeah, but first one is thrown,
Yeah.
and then later on a second one is thrown.
Yeah.
So do they, as time passes, do they stay the same distance apart, or do they get farther apart?
I think still stay the same.
You think
But we should ignore the random factors.
I'm Manu.
graduate student.
I'm a graduate student.
Oh yeah, which year are you?
I'm in my 3rd year. I do quantum gravity, algebraic quantum field theory, more theoretical physics.
Okay.
The relative acceleration in the y direction is 0. So
Wait, in the y direction.
the relative, the relative, like both of them are accelerating at the same rate. And so therefore, there will be a relative velocity, and the relative velocity would be constant. And that would be increasing. So just at the initial time, probably they are the closest. And then in the y direction, I think that's
Yes.
should be true. Yeah.
That is the right answer.
Question 2, the challenge question. The sun pulls on the moon with about twice as much force as the Earth does. Yet during a solar eclipse, when the moon is between the Earth and the sun, the moon stays in orbit around the Earth. Why does the moon stay in orbit around the Earth instead of getting pulled away by the sun? Here's a picture of what happens during a solar eclipse. This is the moon. The moon orbits around the Earth. And at this particular time, the moon is between the sun and the Earth. The sun puts a gravitational force on the moon, and it pulls the moon towards the sun. The Earth also puts a gravitational force on the moon, and that pulls the moon towards the Earth. The force the sun puts on the moon is about twice as large as the force the Earth puts on the moon. Let's do the calculations to show this is correct. Newton's law of gravity is gmm over r squared. This is the mass of the moon. This is the mass of the sun. This is the mass of the Earth. We can easily calculate that the force the Earth puts on the moon is about 1.9 times 10 to the 20th newtons, and the force that the sun puts on the moon is about 4.3 times 10 to the 20th newtons. So the sun exerts 2 times the force on the moon as the Earth does.
Acephysics.org, Math and Physics Tutoring with Dr. Hudis.
I think the fact that the moon is so much closer to the Earth, the force finally has to be much larger. The Earth has to be pulling the moon at a much larger force, and the acceleration provided by the Earth's force will act in this centrifugal direction. And so I think it is probably not correct that the sun pulls more.
My name is Leo, doing 6-4 Artificial Intelligence and Decision Making. I'm a first year. Well, it has velocity going this way. So, like, it'll at that point in time, like, maybe the sun is pulling with double the force, but it's going to escape that, like, location because it has, like, tangential velocity.
Right. That's a good answer. Sure.
That's interesting. I didn't know that the force that the sun put on the moon was greater than the Earth. I think my instinct would be that when you have more than 2 bodies moving under gravity, it's just really complicated.
Maybe because the moon has some sort of, I don't know, like it's already orbiting Earth, so maybe there's a force that keeps it, maybe not a force. Is it centrifugal force or something that keeps it, like, that kind of counteracts or balances the force from the sun and keeps it in orbit around the Earth?
But I guess the moon's a lot closer to Earth, which is why the Earth's pull is felt a lot more, even if the moon's gravity is a lot higher.
You got a lot of them right, but that one you got wrong.
I think because of the balance of the force, like Lagrange's point.
Lagrange point?
I'm not sure, but something like you can find a point that the gravity from the Earth is equal to the gravity from the sun.
Mm-hmm. Yeah, I would actually be curious to calculate that, because I've never thought, I always assumed the Earth force was much larger, but I guess I don't know for sure. I mean, if that's the case, even still, the force is setting, like, the sort of centrifugal motion of the moon around the Earth. But in the same way, the moon is still orbiting the sun as well. It's just at a much larger radius. So you still have both of those things can still be satisfied at the same time.
The sun pulls harder on the moon than the Earth does, but both the Earth and moon orbit the sun together with nearly the same acceleration. As a result, the sun's pull cancels out in their shared frame, leaving only a small tidal effect. Earth's gravity still dominates locally, binding the moon in orbit. Despite the sun's greater force, it doesn't disrupt this bond because it acts almost equally on both bodies. The moon stays in orbit around Earth because the relative force between them is what truly matters. If you have a clear or creative way to explain this, please share it in the comments.
Acephysics.org, Math and Physics Tutoring with Dr. Hudis.